Okay, today we're working on trig problems, okay? Now, just like any problem-solving question, we're going to read through it once, then go back, read through it a second time, get important information out of this, and then create a diagram to help us make sense of this. So, a ship travels 100 kilometers at a bearing of north 60 degrees east, and then turns and travels at a bearing of south 20 degrees each before reaching its destination. If the ship had traveled directly from its starting point to its destination, how far would it have traveled and at what bearing? So, important information. There's quite a bit here in these few sentences. A ship travels 100 kilometers at a bearing of north 60 degrees east, and then it turns and travels from there after 100 kilometers. Oh, there's a part missing. 80 kilometers. It's supposed to say 80 in here, and I'm going to write that in for us, because otherwise we're missing a little bit of information. Travels 80 kilometers at a bearing of south 20 degrees east before reaching its destination. If the ship had traveled directly from the starting to its destination, how far would it have traveled and at what bearing? Okay, so they're asking us two questions here. So we're going to actually have to set this up. So we're going to go down. We're going to assume this is, well, it's obviously a spaceship they're talking about, right? It's my spaceship. I like it. Spaceship. Okay, so we have our spaceship here. Just as a reference point, traveling directly up is going to be our north. Okay? You need to have a strong grasp of north, south, east, and west. If you don't, look it up. Yeah, never eat, try to eat. Very good. So, when they're first talking about north 60 degrees east, we're looking at 60 degrees east of north. So in other words, we're creating an angle like this. That is 60 degrees. Okay? So we're going to say the ship first travels here. That's its distance. It goes a distance of 100 kilometers, as we had read. And it makes an angle of 60 degrees, okay, with north. From there, it turns and starts to travel south 20 degrees east. Well, I still need a reference point from here. Oops. I want that a solid line. South is directly the opposite way of north, okay? And when they say south 20 degrees east, well, they mean 20 degrees east of south, okay? So in other words, this ship then turns and flies at an angle like this. It's not as pronounced of an angle. This is 20 degrees, okay? And it's 80 kilometers. The true question asks us, if the ship had just started from its starting point and went straight to its destination, at what bearing and how far will it have traveled? Well, in other words, they want to know if we'd gone from here to here, how will we have done? So we're going to need to figure out quite a bit of information about this, okay? First things first, we don't know if this is actually a flat line or not, so we're going to switch this around a bit. This might be on an angle. So I'll turn it up just a little, okay? Just so you don't get the fake idea that that might be a 90-degree angle. All right, so we need to figure out essentially what these angles are inside of this triangle, okay? We have measurements. We know that this distance here and this distance here. But we need to find out our parts in the middle, okay? Now, first of the things we can do here is we know that this line and this line, our reference points, are parallels. So we're going to take a bit of that information. This is parallel to this line here. Okay, north and south run on the same parallel axis. Which means, according to one of our patterns, that if this is 60 degrees, this part in here must be what? 60 degrees. Okay, great. If that's 60 degrees, and this angle here is 20 degrees, the entirety of this angle is what? 80. Good. So this is 80 degrees. We have 80 degrees, 80 kilometers, and, well, I'll move this over so it's a little clearer. This is 100 kilometers. I have three pieces of information. Am I able to figure out from here other parts of the triangle with three pieces of information?
Oh, yes.
Yes, we are. We're definitely able to figure out the three pieces of information. With these three pieces, what formula do I want to use to solve for this other side of the triangle? Anyone know? Nope, definitely not. Can't use Pythagorean's theorem because we don't know if this is a 90-degree triangle. Cosine. Okay, our cosine law. Why not sine law?
Yeah.
That's right. We don't have an opposite side and angle. So I don't know this, but I do know that. I know this, but I don't know this. And I know this angle, but I don't know this side. So we don't have that ratio to set up, so we can't use our sine. So we have two sides and an angle enclosed by both, which means we're going to use our cosine law to solve this. We're going to name this C, just like our formula. So this will be angle C here, that 80 degrees. So we're going to go through this question here. Our C squared is equal to A squared plus B squared minus 2AB cos C. C is our unknown, so C squared is equal to A. We're going to call this angle A and this angle B, okay? So A will be 100 squared plus 80 squared minus 2 times 100 times 80. And cos C is what? Cos what degree? 80. Remember, we discovered that the whole angle was 80 degrees. So this is 80 here. From here, we'll work this out with our calculator here. 100 squared is what? 10,000? Yep. And 80 squared is 6,400. So we have 10,000 plus 6,400. And then we have our negative 2 times 100 times 80. Negative 16,000, or in other words, subtract 16,000. You can look at it like that. Cos 80. I must, don't make this mistake, I must do this part first because of our multiplication. So, this negative 16,000 times cos, I gotta put 80 cos, equals negative 2,778, we'll round it to. Negative 2,778. What is 10,000 plus 6,400? Good, 16,400. We're going to subtract these two values. 16,400. Subtract 2,780. 13,622. 622. What do I got to do to get the actual measurement? Yeah, we're going to root these. C, excuse me. C is going to be equal to 116.7. 116.7 kilometers. So if this spaceship had just went from the start to the beginning, instead of traveling 180, it would have just traveled 116.7 kilometers, saving on whatever fuel they use in space to travel. But that's not it. Sorry, that's not just it. That's one part of the question. They asked us one other thing. What do we need to know? Bearing. What does that mean? What do I need to know in terms of the bearing? I need to figure out what this angle is in here. What law can I use now that I've used cosine law to figure out this angle? We can use sine. It'll be a little easier because we now have an actual ratio of 116.7 and 80 degrees. So we're going to set that up with the 80 kilometers to figure out our angle B. Okay? So I'm only going to do half the sine law since you guys are so good with it. I'm just going to do sine C over C is equal to sine B over B. Because those are the only parts of the information I actually need right now. Angle C, we just figured out, or sorry, we already knew was 80. Side C, we just figured out to be 116.7. Sine B is our unknown. And side B is 80 kilometers. Okay? Now, instead of doing this all in decimal form, I'm going to show you how you can type this in your calculator in one shot by using algebra first and then typing it in. So the first thing I need to do is what? Move the 80. When I move the 80 over, it's like putting it on the top of a fraction. Okay? So 80 multiplied by sine 80 divided by 116.7 is equal to sine B. I need to get B by itself. What do we do? So this is what I could type in my calculator. The sine inverse of bracket 80 times sine 80 all divided by 116.7. You can put that all in your calculator in one shot. Okay, instead of rounding decimals out. And this will give you a final answer, exact.
42.43.
Okay, this is good. 42.45. Okay, we're going to round to 42 because we're looking at degrees. So 42 degrees. Now, this is where the bearing gets difficult because of the way I drew this triangle. I want you to think. Okay? That means this is 42 degrees. Okay? So, from north, what bearing did we go? We definitely went in an easterly direction. At what degree, though? How do I figure out that full degree? What do? We add the two. We add the two together, and we're going to figure out at what degree. So, 60 plus 42, 102. Would I, here's a question now, would I say north 102 degrees east? It won't be west. Think about it. If we start north and we go 100, to go from north to east on this little thing I've drawn on the left, how many degrees do I need to go? 90. Have we gone past 90? Yes. So are we still going north? No. What are we doing now? We're heading south. What are we going in terms of south? We need to figure out this little angle here. Well, from 90 to 102 is what? 12 degrees. Good. So this little angle here is 12. But when we write a bearing out, it's from south. So how do I figure out our final answer? South. What bearing east? Yeah, 90 subtract 12, and what would we get? 78 degrees. So his bearing would be south 78 degrees east. So the way I've drawn this is a little misleading, right? And that's the whole point of the question. It actually needs to be heading down this way. Okay. So a lot of thinking in terms of bearing in this question. This is, again, an extended question. So you won't have something that's so intricate at the end here. But the processes, the formulas are the exact same. You guys know them all. You've used them before. You guys are genius.